So let's move on to how are you integrating sustainable practices into the design phase of the new aerospace products? Chris, if you want to start on this one.
Yeah, I think the key here is to understand what the requirements of our aerospace customers are. And we know that there are regulations, we know that there are tolerances, we know that there are materials that our aerospace and defense customers need. And so as we develop new products and new extensions of our offering, is to make sure that we work with our customers hand in hand to be able to settle what their needs are from the first time that we launch a product. So we have those conversations with our salespeople and deliberative and consultative conversations. That goes into my group. And then we work together as a team with our manufacturing partners and our engineering and our software partners to make that a reality and make sure that we do it in a way that protects intellectual property, that meets government standards such as ITAR, and work together to make sure that we keep all of those designs sacrosanct within our capabilities. And it's both again, as we've transformed into the digital space, it's not just keeping a physical drawing on site in a work cell anymore. There's a digital thread that needs to be maintained for safety and security. But it starts with knowing the customer needs.
Yeah, and to add to that, performing a life cycle assessment that's directly connected to the engineering bill of materials is key. Getting this assessment in real time and making it visible to all the stakeholders, you're able to push awareness of the impact and drive them to look at different alternatives that have less environmental impact.
Can you guys discuss the role of advanced materials like the carbon fiber and composites in improving aircraft performance and sustainability?
Sure. So carbon fiber, reduces weight and improves aerodynamics. It increases durability, and it really makes carbon fiber a good choice towards sustainability goals when it comes to, choosing your materials. Because with lighter weight aircraft, of course, the fuel usage is decreased and lowers the carbon footprint. In terms of durability, carbon fiber and composites parts outlast components that are made from other materials, so there's less of them to produce and therefore less energy consumption that's required in the end.
I think you hit on a really key facet of that, which is what is the cost per pound? Every per kilogram, every gram, every pound of payload requires an immense amount of fuel to push it up into the sky or into the space orbit. So we have to be very cognizant as suppliers to make sure that we offer the materials such as aluminum and titanium to make sure that we can help our customers attain that goal. And as Tanya said, hit those sustainability goals. In the end, it comes down to cost too.
Yeah, lightweighting is such a huge part of the aerospace industry. From a multidisciplinary engineering standpoint, how can these design choices impact the supply chain resilience and visibility?
I think we are in the cusp of a technological revolution, and I can speak from a Proto Labs perspective where we offer CNC machining, injection molding, and 3D printing. We had an aerospace customer called Hynetics, and they actually were doing a heat sink, and they were trying to figure out a much more effective, high efficiency heat sink that was also light. So they had to go with an aluminum type of capability, and they moved from a water cooled heat sink into an air cooled heat sink, which unfortunately causes you to have more surface area, right? But with the technology that Proto Labs hosted with a GE 3D printing X machine, we were able to get them a lightweight, very efficient, 90+% efficiency heat sink to enable their customers to get into that sustainability area. So I think it's a matter of choosing the modality of manufacturing that works for you. We would never have been able to machine that sort of intricate design that had to be 3D printed You wouldn't be able to injection mold that because it wouldn't be able to be the metal that you need. So it's looking at the needs of the end use, and choosing the right manufacturing method or materials to get you the results that you need.
Yes, exactly. Designing products with a modular approach so that you have the flexibility to, shift based on the demand or disruptions in the supply, so that if a part may have been, initially planned to be produced with subtractive metal removal, but you can shift gears and produce it with additive, really leaves the door open to produce it another way.
It's nice that we have choices like that to get that extra surface area with the 3D printing as well.